In the previous video, we looked at this spectrum of a Wolf-Rayet star. In this video, we'll look at stacking a different star. You'll recall that the FAQ has a checklist. Let's use it in this video. I'll click on the FAQ button and then click Appendix. Here's our checklist. The first step is to open the folder containing the images for this stack. Okay, let's move this down here until we need it. So I'll come over here, and as we've seen before, click on the ellipsis. We can see at the top and bottom in yellow the folder that I'm currently in. Okay, let me come up here and I'll click on Nova Ophiuchus. Here we can see the list of files in that folder, including these raw CR2 files that I want to stack. Even if you're not using raw files, this video will have a lot of helpful information for you, so stick with us. I'll click on the Select button, and notice back here in the stacking window, there aren't any files listed. That's because the file mask here is set to FITS files. But RSpec is suggesting that we select the wildcard *** to show all the files in the folder. I can do that, but since I know what I'm looking for, I'll just select this CR2 files option. So there are all the CR2 raw files in the folder. Okay, so what's next on our checklist? We've done these first two steps. The next one is to browse through the files and look for a good one. Before I open any files, I want to show you that if I click on this gear icon, the setup screen has an option to play a sound when I open any stacking file. I usually leave it on, but you can turn it off here if you don't like the sound. So to open any file in the grid, I just double click on it. So looking at the image I just opened, we can see it's a color image. The images in this video were captured with a C11, a DSLR, a prism, and a star analyzer. It's really a noisy image, isn't it? And that's where stacking will really help us out. So here's the history of this object. In early September of 2025, a few months before I'm making this video, a classical nova was discovered in the constellation Ophiuchus. Most of you are probably aware that a classical nova occurs when a white dwarf star in a close binary system accumulates material from its companion star until a runaway thermonuclear explosion occurs on its surface. We're going to look at the spectrum of such a nova here. So here's the nova's light curve from the AAVSO. The images that we're looking for in this video were captured just a few days after the discovery. The nova was at magnitude 12, and over the next handful of days, it dimmed back to magnitude 14 or 15. So wow, we're going to have to really dig deep to extract a spectrum from a target with about magnitude of 12. Although most of us don't pursue objects quite this dim or have 11-inch telescopes available, the steps we'll go through in this video apply to almost any target and any hardware. Well, I want to confess I've deliberately taken us down a bit of a dead end here to get started because RSpec doesn't stack these raw image files directly. But we can convert those raw image files to FITS files and then stack the FITS images. Let's see how we do that. First, I'll come over here to Tools and select Convert Raw Files to FITS files. Here in this first field, we need to tell RSpec where the raw CR2 files are located. I'll just click on the ellipse button and select our Nova folder. Great, now we've filled in this field. And for the file, we'll use a wildcard for CR2 files. Now let's tell it where the output FITS files should go. I'll click this checkbox to put them in the same folder as the input files. You know, I think I'd prefer to put them in their own folder, so I'll turn off this checkbox and add a subfolder name, like FITS files. So now I'll click the Convert button. I've sped the video up here. In reality, this took about 17 seconds. So now we're ready to stack those FITS images. This is the folder where they were created. I could copy their path to the clipboard and paste it into the stacking screen, or I could use the ellipse on the stacking screen. But there's this handy shortcut button that does that for us. When I click on this button, the path is transferred over here and the FITS files appear here ready to go. So there's our FITS files. Let's double click on one to look at it on the left. Oh, it's pretty dark. So let's pop up our histogram stretch window. And just to remind you, it has this new checkbox here that automatically stretches images. So this stretched image is definitely better than the color image, wouldn't you say? But which of these are our 12th magnitude nova? This is a wide field image. There's lots of stars here. So let's take a look at this finder chart. Well, that's all very pretty, but I still honestly have no idea how to use this finder chart to find my image. Thank goodness there are people who are better at navigating the sky than I am. So let's look at this zoomed finder chart created by Boyan. I really needed this version, and of course, there's lots of software that can help you with this kind of thing. So here's the zero order image of the nova, and here's the hydrogen alpha emission line, both labeled. And between them is this very dim spectrum we're looking for. So the way I did this is I chose this bright triangular asterism to get me oriented. There it is on our FITS image. And back on the right-hand side, just to the left of this asterism, is that bright hydrogen alpha emission line of our nova. Let's see if we can find it in the RSpec FITS image. There it is. We've found it. So let's zoom in on it. There's the triangular asterism, and there's the hydrogen emission line and the zero order. And there is our dim spectrum. It's not much there, is there? By the way, starting with this new version of RSpec, you can double click on the zoom window to zoom all the way out, which is also what this reset button does. Let's move the zoom window. There we go, it's out of the way here. So let's move the orange lines. I can drag one at a time as usual, or a lot of people don't know this, to move them together, I can hold down the shift key and then click and drag on the outside to drag the lines. So there's our spectrum profile over there. And on the zoom screen, we can use these fine tuning buttons on the zoom to carefully snug up the orange lines close to our dim spectrum. Getting them close eliminates the noise from above and below the spectrum. There, now the orange lines are close to the zero order star and the spectrum. But wait, where's the zero order star up here in our image? It's somewhere out here, I'm sure. For this, I want to show you another new feature in this version of RSpec. In the profile graph, you've always been able to hold Control and Shift keys down with no mouse buttons. And then as you move the mouse hovering over the graph, this vertical line and x-axis value shows up. This can be really helpful when you're reading the graph. And by the way, just a reminder that here on the Appearance screen, on the Lines tab, you can disable the display of that wavelength or pixel value and even change the line's color. So, starting in this update of RSpec, the same Control and Shift over here over the image works the same way. Let's try it. So first, I'll hold down the Control and Shift keys. Then I'll hover my mouse back and forth over the image. And over on the right, we can see the yellow vertical line on the profile is tracking its position. So now I'll wiggle here on the left around somewhere where my zero order is, where I think it should be anyway. And on the right, I can see that the line is going back and forth around a peak on the graph. Here's another way to find the zero order if it's really dim. Get a ruler. Measure the spectrum to zero order distance on a bright star where you can easily see both. Let's see. What's that? That's about 210. Okay. So now I can bring the ruler down here and measure the same distance back from the bomber line to the left, and that's about it. There's the star. And in fact, on the zoom view, It's easy to see too. Okay, where were we? We're looking for a good reference image. I've got my orange lines in place. I'll unzoom the profile. And now I can step through my images by clicking on these buttons, double clicking on the grid row, or Control down, Control up arrow, or even Control P for previous and Control N for next, which is what I usually use. So let's turn off this automatic button since we've already got the stretch set on the first image. That'll make things a little faster. So the current images stretch will be applied to all the subsequent images, which is usually exactly what we want. So we can step through the images, watching the profile graph, maybe zoom in on the zero order, and look for a well-formed or tall zero order. Or maybe we zoom in on a spectral feature and look for low noise around it. Look how this zero order peak is highest on this image 197. So how the images before and after it have a lower zero order. This one looks pretty good. The nice thing here is it's easy for you to experiment by choosing different reference images and regions of interest. And you'll find that your final results are often great regardless of the choices you make. So let's set this image as our reference image. Okay, so what's next on our checklist? We found a decent image and we set it as the reference. So now we need to select our ROI type. With star analyzers, the red capture box usually works best, so let's make sure that's how it's set here. Here's an interesting thing. We don't even have to use a zero order star for our ROI when we're using a star analyzer. We can use any star in the field of view. So while holding down the Control left mouse button, we could choose this as the ROI if we wanted to. Notice you can see the capture box. It appears in the zoom window too now. That's also a new capability in this release. Oh, and there's this option if I right click on the image, I can remove the capture box. In fact, another new feature in this update is that we can draw the ROI in the zoom window now by holding the Control key down as we have before and then using the left mouse button. So that's a pretty good size for the ROI with the margins about a few star widths around it. We'll discuss this more later. And here's a valuable hint. Sometimes it's better to stack on the zero order star, but sometimes it might be better to stack on a feature in the spectrum using the measure lines. We saw that in the previous video. Most of the time it doesn't make a lot of difference, but you'll need to experiment with these different approaches. So what's next? We've selected the ROI type and defined our ROI. So let's check the stacking options screen. By the way, this is a good time to point out this new Reset to Defaults button. It assumes you're doing a zero order star and you can always click it just to get everything back to standard. We'll see a little bit more about it in a bit. And as I've done before, I'm going to check this box to move the main profile to the reference profile automatically when I stack. You know, this stacking options window is so useful. I almost always want it open. So under this setup gear screen is this checkbox, which will automatically open this stacking options window the first time we open the stack screen. I usually leave that checked. And as you've seen, all of these windows take up a lot of space. That's why I really encourage people, get a second monitor if you don't have one. It'll make your life a lot better. You can get just an inexpensive second portable monitor like this for under $100. It's just like a tablet. Okay, everything looks good here, so I can close these screens. Let's clean things up a little bit. Let's turn on our auto stretch. And now, just before we stack, I'm going to grab a screenshot so we can compare this image to the stacked image. And finally, we're ready to go. Let's click stack. Oh wow, look how much that's improved. The stacked image is just so clear, and the old image before stacking is hazy with this noise. It's all gone, all that haze. Spectra over here are crisp and clear. Which would you rather work with? Notice that the vignetting is more visible in the stacked image, but unlike in normal visual imaging, the vignetting really isn't going to affect our spectra. Let's zoom in on the image. Look how clear that spectrum is. Lots of features are visible. And notice these streaks, especially these bright ones. These are artifacts from the camera. And since DSLRs aren't cooled, these artifacts are pronounced. Once RSpec has dark frame subtraction in the future, these streaks will clear right up, but not today. So of course the important thing we want to know is, what's the profile graph look like? As we'd expect, the red curve of the stack spectrum bounces around a lot less because stacking removes so much noise. But you know, the stacked curve doesn't show up very well with the blue reference curve behind it like this. So let's pop up the scaling tool and click this button a few times. And I'll click here to maximize the display. Wow, look at the difference. There are so many features that weren't visible in the original. Look at all these. See these? Where were they before? They were lost in the noise. See these and these? The red stacked image is just so amazingly clear with features. Stacking can bring out a miraculous amount of data. So we're going to shift gears here. You recall from the last video that this column shows how well an image's ROI matches the reference image's ROI. We could scroll around in the grid here comparing those numbers or click on the column head to sort them, but instead we can pop up the plot window. The x-axis here is frame number, and the y-axis right now is ROI fit. This is how well the sub-image's ROI matched the reference image ROI. This isn't an absolute image quality measure. As I hover my mouse across the image, the original file name for that point shows up down here. Let's see, our fourth image here in the grid was our reference image. RSpec set its ROI to 100. And over here on the graph, on image 4, there's the 100 as we expected. You can see that the range of these ROI fit values are from the mid-60s to the mid-70s. If you draw a bigger or a smaller ROI before you stack, that will affect what these numbers are. We really don't care much about their value. We're looking for outliers. And there they are. Something happened in image 21 and image 38. These images have a dramatically lower ROI than the others. Want to look at one of them? It says down here I can control click anywhere on the graph to open up the one under the vertical line. And although there's usually little our eye can see with these kinds of outliers, I can control click on one here because I want to show you the grid scrolls to that row and the image opens. But what causes problems like this? It can be seeing gone bad, it can be cosmic ray, other problems, some of which we'll explore in the next video. Frankly, 2 bad images out of 45 isn't really going to hurt the stacking result noticeably. But suppose there were a lot more bad quality images and we wanted to reject them. How can we do that? Well, first we could control click to open each image like we just did, and then uncheck the box on the grid. Without a check mark, RSpec won't include it in the stack. We could click on the column heading and sort by ROI fit, and they'd all be next to one another. But there's a better way to filter out images of low quality. I'm going to click here to turn back on all the checkboxes, and then open the stacking options window. Right now this button says include all images with check marks, but I can select this radio button and select to set a threshold that images have to exceed to be included in the stack. In the graph, we can see that our best data is above, let's say 58. I'll drag the slider to set the threshold to 58. The next stack will only include images whose ROI fit match is at least 58. Here's how many images will be included and what percent of the original images we're including. That will exclude several of the images down here that fall below that threshold. The plot screen has some other helpful information. Here I'm going to turn off ROI Fit for a moment and display the frame-to-frame movement that RSpec detected in the ROI. And here we can see this red line showing us that from image to image, it was jumping frame by frame this much, just a handful of pixels most of the time. It was tracking pretty well, but here something happened. For some reason, the pixel jump from one frame to the next went up an enormous amount. Something's wrong. It might be, as I said, seeing or a cloud or a mechanical problem. Same thing with this point. And if we turn back on ROI Fit quality, we see that the quality suffered at the exact same point. That's a good confirmation that there was a problem here of some sort. Here's another graph that's available. The red line shows horizontal tracking stayed relatively stable with only minor drift of about minus 24 pixels. The green line shows steady vertical drift reaching 128 pixels over 45 images of 30 seconds each. That's about 6 pixels per minute. If this is an equatorial mount, it definitely needs better polar alignment. So that's all for this video. We saw how stacking images with RSpec helped capture the spectra of a dim 12th magnitude nova. In the next videos, we'll see some additional case studies, and we'll look more deeply into setting your region of interest, as well as how to get the best stacks possible.